TRE. Talk Radio Europe.
Okie dokie, it's bad news, I'm afraid, for those of you who already hate flying. Air travel is going to get a lot bumpier. Severe turbulence, which potentially can land air passengers in hospital if you're not strapped in, will be twice as likely on flights over the next 30 years. Our guest, Paul Williams from the University of Reading, has done some research on the jet stream, which pretty much controls Britain's weather, and that's the bad news. Paul, good morning, welcome to the show.
Good morning, Bill. Nice to talk to you.
And you, sir. Let's first of all start by... turbulence gets a bit of a bad rap, so let's first of all describe what actually it is. What's going on with turbulence?
Well, what's going on is there are instabilities in the atmosphere, especially in the jet stream, as you mentioned, that if the conditions are right, can grow exponentially and become chaotic and irregular and turbulent. And as these air currents push up and down against the wings of the plane obviously moves up and down in response. So it's random motions in the air, just like when you're running the bath or you're stirring some milk into your cup of tea or coffee, just those turbulent motions. Turbulence is present in all fluids, in rivers, coffee, the atmosphere. It's just everywhere.
Yeah, I mean, it's, even for pilots, it's not a pleasant thing, but pilots, of course, know that severe turbulence, even in its most severe form, is not catastrophic because aircraft are designed to withstand a lot of turbulence.
Yes, they are, and that's the important thing to stress, is just how rare even the severe turbulence is. We think that only 0.1% of the atmosphere at a typical cruising altitude contains turbulence that's strong enough to injure people. And the calculations that we've done have suggested that that's going to double or potentially maybe treble. But even then, we're only talking about 0.2 or 0.3%. So turbulence is still going to be rare. That's the important thing to stress.
Yes, I mean, you say injure people. That's really when pilots are pretty aware when they're going to enter turbulence. There are obviously patches of turbulence which they're not aware of. But technology is getting better and better so that they know that it's coming. And aircraft ahead of them on the same airway will, of course, radio and say there's a bit of turbulence coming up. So the seatbelt signs go on, and it's normally the people that ignore the seatbelt signs end up getting injured.
Yeah, that's exactly right. It's those passengers who are not buckled, and the flight attendants. Actually, most of the injuries are to flight attendants rather than passengers, because they obviously have a job to do. But, there's different kinds of turbulence. I know you fly yourself, Bill, so you'll know that there's turbulence when you fly through a cloud.
Yep.
That's always turbulent.
Yep.
But the other kind is what we call clear air turbulence,
yes,
which is the invisible kind. And that's the kind that the pilot can't see coming.
Yes.
That's where the plane in front is a very important source of information, because it literally comes out of the blue, this kind of turbulence.
Yeah,
it tends to be when passengers are wandering around the cabin without their seatbelt and the seatbelt sign not on. So that's why it's clear air turbulence that tends to cause the injuries.
Yes, for people who are nervous flyers, of course, any movement of an aircraft that they're not expecting is a moment of panic, and I totally get that. But, we often see reports, the aircraft dropped 3,000 feet in a second, but it's just not true, is it?
No, it feels a lot worse than it is.
Yeah.
And even me, because I tend to fly a lot, and I've studied turbulence, it's my job. If I encounter a bit of moderate or severe turbulence, I start to think, oh God, what's going on here? The wings shouldn't be bending like that, should they? It plugs into a very primitive part of your brain that cranks up the adrenaline and the fear factor. So, there are lots of nervous flyers. I've seen figures that 1 person in 4 is afraid of flying, and it would be turbulence, I think, that would be the primary cause of that. But it's usually not as bad as it feels.
I interviewed a commercial pilot who writes a website called Ask the Pilot, and he did a particularly good piece on turbulence, and he keeps getting asked about what actually is going on when the aircraft encounters turbulence. How much is it actually moving? And he says, way fewer than 40 feet, normally 10 or 20 feet at most.
Yeah, those figures sound about right to me. Scientists tend to think of it less in terms of the number of feet or meters and more in terms of the acceleration up and down. So that's how I tend to think of it. So we have light and moderate and severe and extreme turbulence, and there's kind of a scale, a bit like the Richter scale for measuring how strong earthquakes are.
Yes.
So,
and of course, if they know that they're going to encounter turbulence, what a pilot would normally do would be ask for a different flight level so he can either go above it or below it.
Well, that's one solution. So we know that the average patch of clear air turbulence is about 1 kilometre thick and about 60 kilometres wide. Those are what the figures suggest on average. So Actually, often changing altitude is not much help because you've got to change by more than 1 kilometre to get out of it. So that's one of the caveats there.
Interesting. Let's talk about the jet stream, because that's something you've done a lot of research on. We often hear talk of the jet stream, and most people, I guess, are not really sure what it is, but we keep seeing, weathermen talking about it on weather charts. Let's have a little chat about the jet stream. What is it, and what is it doing?
I think of it as being like a river of air. It's blowing from west to east in the mid-latitude, so somewhere around 40 or 50 degrees north. Mm-hmm. It can blow very fast. It can reach 200 or even over 200 miles an hour. It tends to wiggle around. It goes north and south. Sometimes it blows directly from west to east. Sometimes it develops a wave in it, and it gets stuck in a certain pattern that tends to give us extreme weather and heat waves and lots of snow if it happens in winter. So it's one of the main drivers of weather in the UK and in Europe is this jet stream.
Yes, and of course, if you're travelling by air, it's like going upstream if you try and head into the jet stream going in the wrong direction. But of course, it'd be very beneficial to come the other way.
That's right. If you're on a westbound flight, it's like trying to swim against a current. It just slows you down, those strong headwinds. And that's why, as anyone who's flown over to North America and back will know, that the westbound journey usually takes about an hour longer than the eastbound journey, and that's just because of the jet stream. The eastbound flights try to get into the jet stream. The westbound flights try to avoid it. And actually that's quite interesting because the jet stream is where the turbulence is. So we believe, or we have evidence, that coming eastbound from North America over to Europe is usually more turbulent. There's usually more turbulence than when you go westbound over to North America, and that's just because of the jet stream effect.
Is the jet stream only across the Atlantic, or are there jet streams that are similar across the Pacific?
Yeah, it's all one jet stream. It goes all the way around the world. It goes over the Atlantic, into Europe, over Asia, into the Pacific, and then over North America, and then it kind of meets itself at the other end. And there's another one in the southern hemisphere too. So there's two main jet streams, lots of other kind of smaller jet streams as well, called locally, but the two global ones are obviously very important for aviation in both hemispheres.
So it's no respecter of land mass then? It's over the land equally as it is over the sea?
It is, yes. So a flight within Europe or between Europe and Asia would equally be affected by the jet stream.
Oh, interesting. And, of course, now we have the added problem of global warming, and this is what your research is showing, that global warming is going to give us a bigger problem with turbulence. So what's the physics behind that then? Yeah,
it's not obvious, is it?
No.
So here's the link then. It turns out that the global warming is not happening at the same rate everywhere. The different parts of the atmosphere are warming by different amounts, and the key fact is that at about 30,000 feet or 40,000 feet, which is obviously where planes tend to cruise, the tropical regions are warming much more rapidly than the polar regions. So the temperature difference, the north-south temperature difference, which is what drives the jet stream, is increasing. So that means the jet stream is speeding up, and basically a stronger jet stream means more turbulence.
I see. So I guess we can describe turbulence in its simplest form then is when bodies of air are moving at dramatically different speeds meet. So the jet stream getting faster is causing a bigger problem.
Yes, that's exactly it. I mean, the way I think of it, and to go into a bit more detail in terms of the physics, is that it's what meteorologists call a wind shear.
Yep.
So this is just simply the fact that the higher up you go in the atmosphere, the windier it gets. And anyone who's ever climbed the Eiffel Tower will have noticed this, because when you start at the bottom of the Eiffel Tower, usually it's not very windy. By the time you're about halfway up, you can feel the wind picking up. And by the time you reach the top of the Eiffel Tower, usually the wind is very strong. And this effect continues all the way up to altitudes of about 10 kilometers. So that's the wind shear, and it's the wind shear that causes these turbulent instabilities in the atmosphere. So as you increase the jet stream speed, you're just increasing those wind shears and just causing the atmosphere to become less stable.
Right, so I guess then, unless we can solve the problem of climate change, there's not a great deal that can be done about this phenomenon.
Nothing obvious. There's a couple of things that might start to come into play. One is that we do have turbulence forecasts. These are made by two international agencies every 6 hours, and they're used in flight planning. So we have a forecast of where the turbulence is going to be. Of course, they're not exact forecasts. They're about 75% accurate, so it's better than nothing. It's better than tossing a coin, I can put it that way. There is information there, and it is used, but if we could do some more research to improve those forecasts and those algorithms, that could help. And then the other thing is, there is some experimental technology that could allow the pilots to see this invisible turbulence. It's something called a LiDAR.
Yes.
It's very much like a radar, except that instead of using radio waves, it uses ultraviolet light. That turns out to be the right kind of light to use because it gets reflected from invisible density perturbations. So if you shine this ultraviolet light out of the front of the plane and analyze the reflected light, you can pick up where the density perturbations are, and that indicates invisible turbulence. And it turns out, we've done some test flights, we can see invisible clear air turbulence up to 15 kilometers ahead of the plane, and that's just about far enough ahead to allow the pilot to put the seatbelt sign on and get everyone sitting down and buckled in.
Interesting. I've just recently been on, for the first time, a Boeing Dreamliner. I think they've got some kind of flashy nose cone sensors that actually send signals to the rudder and the ailerons and all the other control surfaces to minimise the effects of turbulence.
Yes, I've heard about that. So I think what's going on is there's an accelerometer in the nose cone, and if it detects a sudden drop, it will very rapidly, within a tiny fraction of a second, will adjust the wing parameters to minimise the response to turbulence. I also understand that the 787 and the 380 and the more modern airliners have more flexible wings, and that also helps as well, because the more rigid the wing is, the more the plane will bounce up and down through a given patch of turbulence. So there's all sorts of factors coming into play here. I'm not necessarily suggesting we'll see an increase in injuries because of the atmosphere becoming more turbulent, because some of these other factors will help to put downward pressure on the number of injuries. So we'll have to see what happens going forward.
So I think basically what we're saying is, don't panic. It's not not going to get aircraft with wings dropping off. It's not happened up to now, and it's certainly not going to happen in the future. They're designed to be a little stronger than that. And actually, the most sensible advice is, if the seatbelt sign does come on, then obey it.
Absolutely right. And to be honest, even if the seatbelt sign is not on, I always keep my seatbelt on these days. I used to be a bit relaxed about that, and I didn't used to always do that. But since I've started doing this research, I have to say my personal flying habits have changed, and I do what the pilots do. Always keep your seatbelt fastened whenever you're seated, even if the light's not on, and you're virtually guaranteed to be safe if you do that.
Yeah, there's a lot of nonsense talk about the best place to sit in an aircraft in the event of a crash. Of course, if you're sitting at the front of it, if it plummets into the ground, it really doesn't matter one way or the other. But in terms of turbulence, actually there is a best place to sit, which is over the wings.
I've heard that. So I guess what's happening is the plane is kind of rocking up and down, and the central part of the plane is not moving so much as the front and the back. Yeah. I don't know if there's any truth to that, but it sort of makes sense in terms of physics, I think.
Yeah, I think that's probably about right. Well, fascinating research. Thank you, Paul, for coming on and talking about that. So as they used to say in Dad's Army, don't panic, Captain Mannering.
I couldn't have put it better myself. Nice to talk to you.
And you, Paul. All the best. Cheers.
Okay,
bye-bye.
Cheers.
Bye-bye.
Bye-bye.
Pets, vets and guests with David the Dog Man.